Hello everybody, welcome. Today we're going to be doing Unit 4, Lesson 10, unit and non-unit fractions. So today when you're looking at these fractions that are related to division equations, hopefully you're going to be able to identify patterns, because from these models that you're looking at, once you can identify these patterns, hopefully you'll be able to solve division equations without using them. You'll be able to recognize these patterns and then just be able to use numbers, okay? So today we're going to be working a lot with multiplication, division, and then understanding that they're reverse forms of each other. So don't forget that, okay? So let's get started for just a moment. Let me just get rid of this because we're not going to be using this equation right here. Now, our first one, how many 2's are in 12? How many 2's are in 12? Well, we know this is a division equation because it's asking for how many 2's, or more specifically, how many groups, right? We know that division is the study of groups, okay? So we need to figure out how many groups of 2's are in 12. So how might we solve this equation? Well, we always just want to start off by creating a drawing or a diagram of the number of groups that we have. So let's go ahead and make our 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and let's try to figure out how many groups of 2 fit in there. Well, how might we do that? Just by counting the number of groups. Okay, so 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2, 6 groups of 2, okay? And with division, when we're creating our equation, we start from the top to the bottom, and we can see that 12 divided by 2 equals 6, or 6 groups, right? As you can see right here, we have quite a small divisor, which gives us a larger quotient, okay? If our divisor was, let's say, 12 divided by a bigger divisor, like, I don't know, 4, what's that going to do? It automatically decreases, right? It decreases our quotient. So don't forget that symbiotic relationship between the divisor and the quotient. If the divisor goes up, the quotient goes down. Okay, excellent. So this time, what is 12 groups of 1/5? Well, what do we know? We already know the number of groups, right? We just want to figure out what it equals, okay? We already know the number of groups, okay? We know that we have 12 groups of 1/5, or 12 times 1/5. That's how we know we're working with multiplication here, because the unknown is the amount, okay? It's not the number of groups. So, how might we solve this problem? Well, we have 12 times 1/5, so that literally just means 1/5 12 times, okay? So let's go ahead and make 1/5 12 times. Here's our 1/5, and let's go ahead and circle that. Copy, paste, 2/5, 3/5, 4/5, 5/5. So we have our first 1 whole, right? So we know the answer is going to be larger than 1. We have our first 1 whole. We have 5/5, but how many do we need? We need 12 groups of 1/5, 12 groups. So let's go ahead and just copy this to save time. Copy, and let's paste it right here. Okay, now what do we have? 10/5, 10/5, okay? But not 12 yet, so let's go ahead and make our final 2, okay? Our final 2 1/5, okay? So we know we have 2, and then we don't quite have 3, right? We have a fraction of a group here, but what is that fraction? Well, let's go ahead and circle it, copy, and paste. So as we're sizing it up, we notice that it's not a full group, right? If a full group is 5, and this is only 2 out of the 5, it means we have what? Well, 2 out of 5 2 out of 5 means 2/5. 2/5 of a group, right? 2/5 of a group. So what's our answer? Our answer is going to be 1 full group of 1/5, 2 full groups, and then 2/5 of another. Okay, 2/5. So 12 times 1/5 equals 2 and 2/5. Okay, now if we want to turn this into a division equation, we know we just move in the opposite direction, and we do simply 2 and 2/5 divided by 1/5 equals 12. Okay, excellent. Hopefully that's becoming a little bit more clear to you. Now we're going to be switching gears just a little bit. We're going to be figuring out how many groups of a certain number fits into an already established number. So right here we have 6 divided by groups of 1/3. Okay, so 6 right here is represented in what fashion? Well, it seems like in this situation, 6 has been divided into groups of 1, right? 1, 2, 3, 4, 5, 6. But what do we need? We need groups of 1/3. So let's go ahead and divide this into groups of 1/3. Okay? So each of these wholes I'm turning into 1/3, 1/3, 1/3, 1/3. And let's go ahead and do the quicker way just to save time. Excellent. I like how this is working out. Paste and paste. Okay, so we've taken all of those ones and we've divided them into 1/3. Now, what do you think? Do you think the amount of groups is going to increase? Oh, you do? Why do you think that? Yes, exactly. Because the groups have gotten smaller. They've increased and gotten smaller. How do we know that? Well, 1/3 is much smaller than 1, right? Okay, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 groups. So 6 divided by 1/3 is 18 groups, right? 18 groups. And again, you might notice that we have a very small divisor but a large quotient. As that divisor decreases, what happens to the quotient? It increases, right? It increases, okay? So good. You might also notice the 6 right here, the 3 right here. Ooh, how do 6 and 3 relate to 18? That might be something to think about, okay? Now moving down. This time we have 6 divided not by groups of 1/3 but 1/6. So what do we know about 1/6? Yes, it's much smaller than 1/3. In fact, it's only half the size, right? So this time we have our 6 groups of 1, 1, 2, 3, 4, 5, 6, and we must divide them into 6ths. So instead of dividing them into thirds, we're going to divide each of these ones into 6ths. And they're so small that I can barely, I might be able to fit a 1/6 in there. I don't know. It's kind of, well, I'm not even going to bother because it just doesn't look right, okay? Just know that these are 1/6 because we can count them. 1, 2, 3, 4, 5, 6 groups, right? Okay, so let's go ahead and divide these amongst the rest. Okay. And voila, I have successfully divided my 6 into groups of 1/6. Okay, now let's count them. What do you think? Last time we had 6 divided by groups of 1/3 and we got 18 groups. Now 1/3 is exactly twice as much as 1/6. So our divisor has decreased by half. So what's going to happen to our quotient this time? Who knows? Well, let's find out, okay? So we have 6, 12, 18, 24, 30, 36. 36. Okay, so this time what happened? Well, our divisor decreased by half, but our quotient doubled. It increased by double the amount. Okay, interesting, going along with that rule. But what else do you notice? Well, 6 divided by 1, 6 equals 36, just like 6 divided by 1/3 equals 18. Are you able to see a pattern yet? Okay, hopefully you see that pattern and you will be able to apply those principles to these equations down here, where you're able to find the answer without even creating a diagram. Okay, so best of luck to you. Are you able to figure that out? Thank you for tuning in, and good luck.